Welcome back. We are studying here in lecture number 9. We solve this question of circuit theory by mesh and nodal analysis using KVL and KCL respectively. First of all, we solve this problem using mesh analysis. So when we solve this question using mesh analysis, first of all we considering closed path. So here ABCHA is a mesh number 1. Similarly, HCDGH is mesh number 2 and GDEFG is mesh number 3. So there is a ABCDEFGHA is loop. Now considering KVL to write an equation, so for M1 it would be applicable. Now for M2 and M3 there is a branch in which a current source is present. So we explained earlier, if there is any branch containing current source, we cannot apply KVL directly. So we use source transformation in this method or using super mesh. So before starting writing KVL equation, we are considering terminals on each element. So this is positive, this is negative. Now current is flowing from in this direction. It is positive, it is negative. Now here current is entering from the side. So in both way current flowing from downward direction. So it would be I1 plus I2. And this is positive, this is negative, this is positive, this is negative. We apply here I1 plus I2 here. This is positive, this is negative. Now and in this mesh 3 current is flowing through E to F and it would be plus and minus. So start KVL. To write the equation, it would be start from A. It is 10 minus 5 I1 minus 15 I1 plus I2 is equal to 0. So after solving this equation, it would be 20 I1 and plus 15 I is equal to 10. So we solve this equation for KVL in mesh 1. Now apply KVL for loop, means ABCDEFGHA. Start from A, last polarity, plus of 10 minus of 5 I1 minus of 5 and again minus of 5 I3 is equal to 0. So after solving this, it is minus 5 I1 minus 5 I3 is equal to minus 5 and I1 plus I3 is equal to 1. So now we have two equations, and now for this DG it would be I2 plus I3 from G to D is equal to, given here, 2 ampere. So it would be 2 ampere. So we have three equations. This is equation number 1, this is equation number 2 and this is equation number 3. After solving these three equations, we get three values. I1 is equal to minus 0.143, I2 is equal to 0.857 ampere and I3 is equal to 1.143 ampere. So in this way we solve this question using mesh analysis. Now we solve this question using nodal analysis, and we see the concept of super node second, type 2. First of all, we considering A and B are two nodes, and here there is no any element connected, so these 2 points are same, and we consider it is a reference point, reference node. So we considering I1, I2, I3, I4 and I5 in this way, I5. So here we divide our separate our all branches in this way and denoted our relationship for current. So current is entering in the terminal, so it is minus, it is plus because it is supplying by this node, so this is negative positive. So for I1 it would be start from high potential 0 plus 10 minus of VA upon 5, so it is I1. For I4, current is supplying from this node, this is positive, this is negative, it would be VA minus 0 upon 15. Now I5 is given, this is 2 ampere, and for I3 it would be current is supplying, so it would be positive and it would be negative. So I3 would be VB minus 0 upon 5. So I1, I5, I3 and I4 is shown here. But for this branch, for I2, there is no any resistance here. So we cannot apply I is equal to V upon R because there is no R, or internal resistance of this battery is 0. So current would be infinite. So we cannot write this equation. So how to solve this question now? Apply these 2 points here and make all currents at the terminal and at this node all, and we apply super node type 2. So I1 we considering these both nodes as same, superpose in these two, this is I1, this is I4, and we will consider this current, this I2 current disappear. So this is I3 and this is I5. So apply KCL, means summation of all incoming current is equal to all outgoing current. It would be I1 plus I5 is equal to I4 plus I3. So this equation is like this. Now put the value of I1 here, I5 here, I4 here and I3 here from there in this equation. So it would be I1 is equal to 10 minus VA upon 5 plus I5 2 is equal to I4 VA upon 15 plus I3 VB upon 5. So when we solve this whole equation, it would be 120 is equal to twice of VA plus 6 VA plus 6 VB. When we multiply this whole by some multiplication factor and solve this, we get this. And after solving, it would be 8 VA plus 6 VB is equal to 120, and VA minus VB is equal to 5. How? VA minus VB, because there is no any resistance here, so we can say VA minus VB is equal to 5 volt. After solving these two equations, we get VA is equal to 10.7142 volt and VB is equal to 5.7142 volt. After getting VA and VB, we put these VA and VB here in I1, I3, I5 and I4. So we get I1 is equal to minus K 0.14284, I4 that will be VA upon 15, it would be 1.07142, and I3 VB divided by 5, it is 1.14284. So in this way we solve our question. In this method we describe the concept of supernode in which there is no any resistance connected between the nodes. So we solve in this way. Thank you so much. In next lecture we describe some more concept about supernode 1 and supernode 2 along with in the same problem. Thank you.